Example C gives us an angle C of 55.3 degrees, a side length A of 24.9, and a side length C of 22.8. So let's go ahead and draw this triangle. I'm just drawing a very generic triangle. Here I'll label this C, and this is 55.3 degrees. That means that this will be C 22.8, and then I will call this angle A. We don't know that one, so I'll put that. I will call this angle B, and then we know the side length A is 24.9, and then I'm just going to dash this side length since we don't know what that one is, and then I will call that one B. So now what I'm going to do is I'm going to draw my height here and call that H, and then I want to figure out the value of H. So if I do that, I know that H is equal to, maybe that's not how I want to start off. Maybe I want to say that sine of 55.3 degrees is equal to H over 24.9. Now if I solve this for H, I'd get H equals 24.9 times sine of 55.3 degrees, and if I throw that into my calculator, I want to make sure I'm in degrees, which I am. So I do 24.9 times sine of 55.3. That gives me 20.5. Okay, so our height is smaller than this length here, which creates the case where we are going to have two possible triangles. So this is one possible triangle. I'm going to draw the other possibility, and it's going to end up looking something like this. Okay, so here's angle A, here's our B value. Here's C, we know that this is 55.3 degrees. We don't know angle A, we don't know angle B. We know that C is 22.8, and then we know that lowercase a is 24.9. So because this is the ambiguous case, we need to solve both of these triangles because they are both possibilities for the scenario that's given to us here. All right, so let's go ahead and solve these triangles. I'm going to erase this just to give me a little extra room. Okay, so for this, let's see, maybe I should separate the space out here. Okay, so for this first triangle, we're going to do sine of 55.3 degrees over 22.8. So I'm setting up my law of sines equation here, and then that is equal to sine of capital A over 24.9. Then we get that sine of capital A is equal to 24.9 times sine of 55.3 degrees over 22.8. And then finally, if we use sine inverse on both sides, we get sine inverse of 24.9 sine of 55.3 degrees over 22.8. Now notice that this equation here is actually going to have two solutions. When we plug in sine inverse into our calculator, it's only going to give us the angle that is the acute angle that's drawn here. However, if you think about the unit circle, there's going to be an acute angle somewhere in quadrant 1 that's going to have that sine value. But then there's also, if you reflect it over the y-axis, there's also going to be an obtuse angle in quadrant 2 that's also going to give that sine value. So we have to think about that later to think about this second angle A. So we'll approach that in a little bit. Let's go ahead and throw this into our calculator. Okay, so I want to do, why don't we just calculate the inside of the parentheses first? So 24.9 times sine of 55.3 divided by 22.8. Okay, so there it has a value of 0.89. I'm going to round that to 9. So what that means is here on this ordered pair, the y value is 0.9, but there's also another y value with 0.9 here at this second angle that's in quadrant 2. So when we do sine inverse of 0.9 or whatever that number there is, we get 63.87. So I'm going to round that to 63.9. So A is equal to 63.9 degrees. And the way that we're going to figure out A in the second triangle is we know that the reference angle here is 63.9 degrees. And so to figure out this angle, we're going to do 180 degrees minus 63.9 degrees. So oops, that's not what I wanted. So A equals 180 degrees minus 63.9 degrees. And let's just throw that into our calculator really quickly. So that is going to be 116.1 degrees. Okay, so we solve for angle A in both of our triangles now. All right, so now in our first triangle, we can figure out angle B by using the fact that the sum of the angles of a triangle is 180 degrees. So we could do 180 minus 63.9 degrees plus 55.3 degrees. Okay, so then angle B is 60.8 degrees. So I'm going to fill that in here. And now we just have to figure out the side length B. And I'm going to erase this just so that I can make some room. Okay, so I'm going to need to use law of sines again. So we can say that 22.8 over sine of 55.3 degrees is equal to lowercase b over sine of 60.8 degrees. And if I solve for lowercase b, I get sine 22.8 times sine of 60.8 degrees over sine of 55.3 degrees. Okay, so we get that B is 24.2. Okay, and so I'm just going to highlight all of the values that we found. Awesome. So those are our final answers for that first triangle. Okay, so in this second triangle, we can calculate angle B by doing 180 degrees minus the sum of the other two angles. So 116.1 degrees plus 55.3 degrees. So 180 minus 116.1 plus 55.3. Oh, that's a small angle. So B equals 8.6 degrees. Now that we have that information, we just need to figure out the side length B. So we can do 22.8 over sine of 55.3 degrees is equal to lowercase b over sine of 8.6 degrees. And then if we manipulate this algebraically, we get that b is equal to 22.8 times sine of 8.6 degrees over sine of 55.3 degrees. And we are throwing that into our calculator. And we get 4.1, which seems like a reasonable answer since we've solved for the angle B and it was like a smaller angle, so our lowercase b value side length is going to be a smaller number. So b equals 4.1, and we solve for capital A, capital B, and lowercase a. So that concludes this example.